G'day, today I'm just going to have a look at this guy here, and what this is, I'll just see if I can get it to focus on it, it's a 6139 case with the replacement PLEXI crystals. Hear that? That's plastic. So anyway, my opinion on these has always been that when you're replacing a glass crystal with a PLEXI, the PLEXI isn't going to perform the same. The reason being that the PLEXI is much more flexible, and my opinion was I didn't really see how the plastic crystal could sit inside the rubber seal and not really move. Reason being that it was designed for a rigid part, whereas the plexiglass is a flexible part. So my opinion always was that the plexiglass is going to flex and it's going to jump out of the gasket. The rubber gasket that goes around the outside under here. So normally with a plexi crystal, they just mount straight into the case without any seal or anything, and the crystal becomes the seal itself. So anyway, I'm going to put it to the test and we'll get a definitive answer on this one. So I've taken the dial off and stuff in case it explodes, and I've given the case a real chance to pass this. So I've replaced the seals on the pushers and also the crown and the back. So we'll put him in, and we've got sensor there. So the way this works is it's going to do two tests. So the first one's a vacuum test and the second one is the pressure test. So in the vacuum test, it's going to suck, this chamber is going to come down, it's going to suck all the air out, which is going to create basically a lift. And what's going to happen on here is it's going to give a reading. I'll just see if I can, there we go, that's a bit better. It's going to give a reading on how far that crystal is lifted up from the zero position that it's measured right there. And it gives it some amount of time for the crystal to stabilize. So in theory it should move a certain amount and then probably not much more. And then it will stabilize and then it will take a measurement. Now the second test is the pressure test. So in that test it pumps air in. So you're creating a pressure inside the chamber there. And it's basically the same. So what it does is it will measure the amount that the crystal pushes down. Because if you've got pressure, the crystal's going to go down. It gives it a certain amount of time to stabilize, and then it takes a measurement, and that's it. So I'll start with a 2-bar test. So that's 20 meters. So you can see that there. So it's 20 meters pressure and minus 4 bar in vacuum. So that means that it's going to have create a larger vacuum than it will pressure. And the maximum allowable tolerance on this is minus 2%, which is reasonably typical. So we're going to give it a go. So I'll just make sure that's all set. There we go. So now it's just sucking the air out now, and we're going to watch the numbers there. So it takes a measurement in microns, so that's what, 1/100th of a millimeter, I can't remember. And we're in the stabilization period at the moment, so you'll see it's lifted up. Yeah, so 83.1 microns. Now it's going to take a measurement, and it considers that a pass, but it was just barely a pass. So now we're going to pressurize it. You can see there it's had a reasonable amount of push down on it, so that's normally more than what you'd see on a glass crystal. So just bearing in mind this is only 2 bar as well. So you can see the numbers are still changing there, so that the figure's still stabilizing. It hasn't fully stabilized yet. It is starting to slow down though. And I think it's just about to stop now. Yeah, it looks like it's stabilized about that point. Now what the machine will do is it'll just take a measurement of how far it thinks it's gone down, as in the crystal's being compressed due to the pressure. Alright, so 2 bar, that was a pass, and it's given us a margin of 1.6% on the pressure and 1.9% on the vacuum. So that's just within the allowable tolerances for that. So the long and short of it is as long as you replace the seals, the plastic 6139 replacement crystals will pass at 20 meters. So if we now take it up to, typically I test these at 5 bar, which is 50 meters. So we're going to give it a shot at that. Alright, so now we've got full vacuum in there. And you can see there the numbers are still changing. So that is the crystal, well, it's the little micrometer on top of the crystal measuring the crystal go up. And we're just about to get a final measurement on that. Alright, so that was a pass. This test actually has, I think it was a 3% variation. Alright, so now we're fully pressurized at 5 bar. And I think because the sensor light's going to go off, we may even get a fail on this. It just means the crystal compressed too much. You can see there it's nearly stabilized, not quite. I think it's just stabilized now. And now we're going to get a final reading on it. So okay, so that passed as well. So I'm just visually inspecting it here now. Nothing really seems to have popped out or anything like that. Alright, so let's just for experimentation's sake, we'll try a 10 bar, which is 100 meters, and just see what it does there. So normally, if I leave this on with a glass crystal, it will definitely pass even 100 meters, even though they're not rated to that. They are quite well built, so they will pass that. So we'll just try that now. Alright, so now we've got full vacuum. And we're just waiting for the crystal to stabilize now. So the reason that these machines use that system of measuring, as in the crystal deflection, is because it's actually a pretty accurate way of measuring whether you've got a sealed case or not. So what will happen is if the case is not sealed, one of two things will happen. You'll either get air leak in, and the crystal won't deflect at all, or you'll get some air leak in and the crystal won't have enough deflection on it. And what usually happens if that happens is you'll undo the crown and you'll have a little gust of air come out, and that's just pressure that's got in there and has been trapped in there. So obviously that's not really what we're after with having a sealed case. But yeah, no, the reason that it's so accurate is because the way these cases are designed is basically to do exactly that. So it's actually quite a good real-world test overall that's non-destructive that you can use to do this sort of thing. I just actually heard a twang in there, so that suggests to me that we may have lost the crystal. We'll find out in a sec anyway, but yeah, as I was saying, these tests are quite good because they're non-destructive to the watch unless the crystal explodes, and also they give a good representation of how it's going to perform in those pressure environments. Now, I mean, ultimately, you're not going to be going into a vacuum probably unless you're in space, but definitely the pressure is very valuable. But the vacuum is good because if it fails the vacuum test, it's very rarely going to pass the pressure test. So I think based on that, we can probably conclude that, now obviously I went over, I'm just going to move this around so that you can actually get a better view of it. So I think we can probably conclude from that now it did, for some reason it did give a pass on the pressure test, which it probably shouldn't have, but that can happen. So just going to have a zoom in on that one. So that one is totally shattered. Now obviously we tested that to a higher pressure than it should have been tested to. However, my point there is that that doesn't happen if you've got a glass crystal in there. So I think that while it did pass these pressure tests, I think really the conclusion to come to with these plastic crystals is that they're probably okay at 2 bar or something like that, but if you're really trying to get anywhere close to the original water resistance, they're just really not going to cut it. Yeah, I mean that's not a good result, but yeah, I mean some people do prefer them over the glass. I have people say all the time, oh, just put the plastic crystal in there, and I've always been resistant to it. But I mean, just this result now, I mean, even though it was higher than what we were trying to achieve, the other thing I have to consider as well is that even at the 5 bar test, the sensor light went off, which means that the case moved outside of the sensor range. So that's usually a bad sign as well. That means you've got too much compression. So my conclusion on it is that these plastic crystals are crap. Don't use them. Just spend a little bit extra and get the glass one, because it will do what it's supposed to do, and it will pass a pressure test where it's supposed to. Just the sealing system in here really just isn't designed for a flexible crystal, and that's what you're getting with the PLEXI. Alright, so I'm going to wrap that up there, and yeah, look forward to doing another video soon, and yeah, subscribe and all that sort of stuff as well. That'd be great. Thank you.